This is AS Module 2 paper from June 2010. This is question 2 and the topic is refraction. 2A then. In an experiment to measure the refractive index of glass, a series of results for a range of angles of incidence and their corresponding angles of refraction has been obtained. Describe how these results may be processed to obtain an accurate value for the refractive index of glass. So it is not asking us to describe the experiment. Take care that you read the question here. What they want is how the results may be processed to obtain an accurate value of the refractive index of the glass. Well, the first thing is from the results is to calculate sin I and sin R. And then if we plot a graph of sin I against sin R with sin I on the y-axis, the gradient of that graph is equal to the refractive index. Now note there are 3 marks for that question. There was 1 mark for saying you calculate sin I and sin R. The second mark was for plotting the graph with sin I on the y-axis. And the third mark was for saying find the gradient, and that's equal to the refractive index. The other alternative to that is to again calculate sin I and sin R. You could then calculate the ratio of sin I over sin R for pairs of angles and find an average of that value, which is equal to the refractive index. You must have some form of repeatability in there to ensure accuracy for the value of refractive index. If you simply take one pair of values and calculate the 2 signs and find the refractive index, you can't be sure that the experimental results were accurate for that particular pair. And that applies both with the graph or the averaging idea. Part B then. A ray of light travels from inside a block of transparent material to air. So it's from inside to the air. The refractive index of the material of the block is 1.38. That's useful to us. The ray emerges from the block into the air at an angle of 43 degrees to the normal. Calculate the minimum increase in the angle of the ray inside the block. So we're interested in the angle of the ray inside the block to cause this ray to undergo total internal reflection. Well, first off, we need to find what the current angle of incidence is. When the angle of refraction is 43 degrees and the refractive index is 1.38, we need to find the current angle of incidence because we're trying to find the change in it. So we need to know what it is currently. So our equation, sin of I over sin of R is equal to 1 over n, because we're going from the block to the air. We must use the reciprocal of that refractive index. Therefore, sin of I is equal to 1 over 1.38 times the sine of the refracted angle, which is 43 degrees. This gives us an angle of incidence of 29.62 degrees. We also need to therefore know what the critical angle is, because we want to increase our angle of incidence to be just equal to the critical angle, and above which point then we will have total internal reflection. So sine of C is equal to 1 over n. So C is equal to the inverse sine of 1 over 1.38. And that gives us a critical angle of 46.44. So the increase in I that we need to have is up to the 46.44 from the 29.62. So we find the difference, which is 16.8 degrees. That means we need to take the angle of incidence from 29.62 and increased it by 16.8 degrees to meet the critical angle of 46.44. Now, in that question there are 5 marks. The first mark was for substituting in correctly into the refractive index formula. Second mark was for calculating the original angle of incidence. The third mark was for writing down or substituting into the critical angle formula. The fourth mark then was for finding the critical angle, and the fifth mark was for finding the difference or the increase required in the angle of incidence to cause total internal reflection. So any angle above the critical angle of 46.44, at this point the ray will undergo total internal reflection and there will be no refraction. So let's remind ourselves what the question in this exam was about. We had a total of 8 marks. The first one was describing how the results of an experiment may be processed to find an accurate value for a refractive index. And the best method is to calculate sin I and sin R, plot a graph of sin I against sin R, and find the gradient, and that is equal to the refractive index. An alternative there is to calculate sin I and sin R, find the ratio of sin I to sin R for a range of pairs of values, and then find the average of those calculated values. The second part of the question then asks us to find how much an angle of incidence must be increased by to cause total internal reflection. The first part of the question, we calculated the original angle of incidence according to its angle of refraction and the refractive index. We then calculated the critical angle for that transparent material of refractive index of 1.38, and to find the increase we found the difference between the two.